students, this is lesson 8.3, unit 8, area and volume. Take a look at your notes. Please make note both of the location, date, and time, and don't forget to get a parent or teacher sign off here. Let's do a quick review here. It says a regular pentagon has an apothem length of 8 meters and an area of 232 meters squared. Find the length of a single side. So step number 1, as usual, is to underline or highlight keywords and info. Now we're going to do this, draw label list. We have a regular pentagon, so let's draw a regular pentagon. Pent is 5. 1, 2, 3, 4, 5. With an apothem of 8 meters, apothem goes from center to side at the midpoint, that's 8 meters. And what else we're told? We're told that the area altogether, area equals 232 meters squared. Okay, so here we draw. If it's not on the drawing, we list it and we label as we can. Cross stuff out as you account for it. We want to find the length of a single side, so we're going to call that X. So you ask yourself, what can you do? And, well, we know it's a regular polygon, so we can at least write the equation out. Area of a regular polygon is going to be perimeter times apothem over 2. Now, perimeter times apothem over 2. Let's circle, plug, chug. Area. We have the area here. So we have 232 equals, so the area is 232. Perimeter we don't know. When you walk it around, since we don't know the side length, we don't know the perimeter. So we're just going to put P here. The apothem we do know, it's 8. And then we circle 2 and bring it over. 2 goes into 8 4 times. So coming this way, we have 232 equals 4 times the perimeter. Divide both sides by 4. So here we have 232 divided by 4. 4 goes in here approximately 5 times. 4 goes into 32 8 times. So we have 58 equals our perimeter. Now, to get our actual side length, since our perimeter is 58, it's going to be 58 divided by 5, because we have 5 sides. And of course, we get 11.6. So one side length is 11.6. So we asked ourselves, what can we do? Equations, 2 sides with an equal sign, circle, plug, chug. Follow that list, you'll never get lost. Let's take a look at what we're doing today. Okay, today there's going to be introducing some important terms here. We're going to talk about circle area, circumference, arc length, sector area, central angle, and something called theta, which is that Greek letter there. We use that for angle. Okay, by the end of the next about 20 some odd minutes, this is the most important thing. You have to be able to explain the difference between. This is absolutely critical. There is a difference between arc measure versus arc length. Arc measure versus arc length. These two terms are not interchangeable. We're going to come back to that. Make sure you know the difference between these two, arc measure versus arc length. Okay, let's start with the basics. It says, find the circumference and the area of the circle below. Assume the radius of 11 is 3 centimeters. So radius equals 3 cm. Let's draw that in. 3 cm. Let's always start by writing your equations. Equations have two sides with an equal sign, so we have right here C d pi, I c d pi. And then this one is apple pie is really, really good. Parentheses around there. So C equals diameter. Physically trace the diameter. Don't let your eyeballs pick up just that 3, because the diameter is all the way across. So our diameter is going to be 6 pi centimeters. Area equals pi r squared, so we put the 3 in right there, so of course that's 9 pi centimeters squared. We can multiply them out so you can see both versions. 6 pi, 6 times pi, we're going to round that to the tenths place, that's going to be 18.8. So C equals 18.8 centimeters. And then this one is 9 times pi. That's 28.3. Area equals 28.3 centimeters squared. So keep in mind what we just found here. What we found, circumference is the distance all the way around. It's a length all the way around. And area, of course, is the inside guts. That would be area. So one is the length around, the other is the area on the inside. Okay, so in today's lesson, if you were to take a piece of the circumference, just a slice of the circumference, that is a length issue, a piece of that length, that's going to be called arc length. A piece, an arc length is a fraction of the circumference. Okay, so that term arc length means a fraction of the circumference. You want to write that in. Arc length is just a portion of the circumference there. Now the term sector area, make a little wedge there. Sweep, shade, shade that in. This is called a sector area. Now all a sector is simply a fraction of the area. So let's recap. The word arc length means fraction of the circumference. Sector area, a sector area is a fraction of the area. These are the two things we're talking about today. The concept of sector area and arc length. That's what we're talking about today. One is a piece of the circumference, the other is a piece of the area. So the way we do this is to find the length of an arc length. Remember that an arc length is simply a fraction or portion of a circle's circumference. It's a fraction of the circumference. Now a fraction is simply a part over a whole. So it's a fraction of the circumference. Now when we're dealing with a circle, the part that we're going to use, when we talk about part, it's going to be the measure of that central angle right there. And we're going to use the variable theta. Theta specifically means the measure of that central angle only. So to find a piece of the circumference or arc length, it's going to be the central angle theta. You might want to make note that that's a central angle. over 360 times d pi. That's circumference. Take a moment and you want to write that down. Let me give you a quick little example. Let's say here our radius is 5 inches. Okay? And let's say our theta here, let's give it an actual measurement. Let's say our theta is 120 degrees. And I want the length of this arc. Now, remember I told you what's the difference between arc measure and arc length. Here, remember, measure of the central angle to its arc the same. So this measure is 120 degrees. Measure is to deal with the degree curvature. So the measure of the arc, let's give it letters here, AB. The measure of arc AB is going to be 120 degrees. Now that's not the length of the arc. The length is if you were to slice this piece right here and you were to flatten it into a flat piece, that would be the actual arc length. And so arc length is going to be over here. Arc length, AB, is going to be a fraction of the circumference. So our fraction here is going to be 120 over 360 of the circumference, which is d pi. Our diameter is 10 pi. We're going to go ahead and work this out. I'm going to bring it down here. So we have 120 over 360 times 10 pi. Yes, I guess you could grab a calculator. This is actually faster if you just get rid of the zeros. We know 12 goes into 36 3 times, so I have a 1/3 here. And here's 10 pi. So my actual length here, you can write it like this. 10 over 3 pi inches. That would be the length of the arc. Or if you like the decimal version, or if you need the decimal version, we're going to do 10 divided by 3 times pi, and that length there is going to be 10.5, approximately 10.5 inches. So that is arc length. Now let's try a sector area. A sector area is simply going to be a fraction of a circle's area. So sector area is part over whole times area. Our part is whatever the measure of that central angle theta is. So you have theta over 360 times area, which is pi r squared. A sector area is just going to be like a pizza slice. So let's use the same numbers that we used before. Let's say our theta here, our central angle is 120 degrees, and our radius is 5 inches. And now I want to find the area of this entire shaded region, the actual area. That's called a sector area equals theta over 360 times pi r squared. So sector area, our theta in this case is 120 over 360 times pi And then we have 5 squared. I'm going to cancel the zeros here. So I have 1/3 pi times 25. So my sector area is actually going to be 25 over 3 pi inches squared. And once you have an irreducible fraction, you can leave it just like that. Perfectly acceptable. If you like the decimal version, we can do this. 25 divided by 3 times by pi. And we get 26.2. So approximately 26.2 inches squared. Both answers are perfectly fine, depending on what's being demanded. So let's walk through a problem together here. And it says right here, it says in the circle below, find the degree, underline that word degree, measure of the arc AC, and then find the length of the arc. Remember, I told you that was one of the main things you need to be able to do, is measure versus length. Those are two different things. Finally, find the sector area. And the radius we're given here is 10 centimeters. So let's put 10 centimeters in. So we're doing this one together. Okay. The measure of the arc, our central angle is 45. So the arc AC, we write it like this. Measure, M, arc, A to C. And measure has to deal with curvature, which is a degree concept, not a length concept. And we learned measure of a central angle to its arc the same. Okay, that's called arc measure. Measure has to deal with the curvature of the circle, a piece of the curvature of the circle. That is different than length. Now, length is a piece, arc length, I'm going to change it to blue, arc length is a fraction of the whole circumference. So for arc length, it equals fraction, which is theta over 360, part over whole, times circumference, which is d pi. That's your equation. It's a fraction of circumference. So here, our theta is going to be 45 over 360 times, trace out that diameter. It's not 10. Physically pick up that diameter, physically trace it over. You should see that the diameter here is 20. So I have 20 times pi. Now, if you can cancel anything, it's easier when you're working on a calculator, so we can cancel the zeros. And we also know 2 goes into 36 18 times. And now I can reduce because both 18 and 45, 9 goes in there 5 times, 9 goes in there twice. So my final arc length of AC, the length is going to be 5 over 2 pi centimeters. Now, calculator style. Back to the calculator. Let's go back to the original numbers here. Let me get rid of all these crossouts. Okay, all the original numbers was 45 over 360 times our diameter, 20, and then pi. For the calculator, you can just multiply straight across if you'd like. So that's going to be 45 times 20 times pi equals, and then divide by 360. And that gets you the same thing. In this case, it'll be 7.9. So the arc length equals 7.9 centimeters. It's a piece of the circumference. Now, if we come up here, sector area is the area of that pizza slice. The area of the pizza slice. So it is a fraction of the area. Sector area is fraction of the circle's area. So your equation is theta over 360 times pi r squared. Our theta here, we already figured it out. It's 45 times 360 times pi, and our radius is 10 squared. That makes 100. So if we want to reduce here, we can cancel the zeros. 2 goes into 36 18 times. 2 goes in here 5 times. 9 goes in here twice. 9 goes in here 5 times. So to reduce, I end up with 25 over 2 pi, and my units are centimeters squared, or calculator version looks like this. I'm going to go 45 times 100, because that's 10 squared, equals, times pi equals, and then I'm going to divide by 360. And you get 39.3. And again, it's centimeters squared. Okay, so to recap here, to find arc length, it is a fraction of the circumference. To find sector area, it is a fraction of the area. Now what I'm going to have you do is I'd like you, this is an incredibly similar problem. I'm going to give you 5 minutes. I'd like you to do this entire page on your own. Use this as a model right here. 5 minutes. I'm going to set the clock here. Use your previous page as a model, and then come back and check it. Please try this on your own. Don't just fast forward through this video to get the answer. Try this on your own, and then check it, please. Go. Alrighty, let's see how we did here. So we know that in this case it says circle EQF has 75 degrees right here. This is 75 degrees. And the radius length is 9 yards. Find the length of the major arc. The major arc EGF. EGF. So let's come close here. We're going to do this in 3 steps. Okay, step number 1. We want to find here, it says first the measure of the arc. The measure is the degree curvature. So measure means degree curve. And the measure of the degree curve is simply 360 minus 75, which we already have, is 285 degrees. That's the degree curvature. That is arc measure. Now, arc length is simply a fraction of the circumference. So what we do there, our fraction is a part, theta over 360, times the circumference, which is d pi. So let's see what we have here. Our fraction is 285 this time because we want the major arc, so we have 285 over 360 times our d, which is 9 pi. Okay, from here, I'm simply going to take 9 into 360, and I'm going to get 40 there. Then I'm going to ask what goes into both 285 and 40 is 5. So 285 divided by 5 is 57. And 40 divided by 5 is 8. So I have 57 over 8 pi. So my arc length equals 57 over 8 pi yards, or the decimal version would look like this: 285 times 9 times pi divided by 360, and I get 22.4. 22.4 yards. Okay, that is arc length, a fraction of the circumference. Now, sector area. Sector area EGF, that's all of this striped area. Sector area is theta. That's going to be theta over 360 times pi r squared, because it's a fraction of the area now. So for this, our theta is, again, going this way, 285. 285 over 360 times pi 9 squared. So I end up with 285 times 81 over 360 times pi. Now if we want to reduce, I'm going to go 360 divided by 81 and see what I get. That doesn't go in evenly, so I'm going to do 285 times 81 equals, divided by 360 equals, and I get 64.125 pi, or we times that by the pi key, and we get 201.4. And this would be yards squared. Okay, it is very important prior to our next quiz that you must have these two memorized. Arc length is a fraction of sector area is a fraction of the area. Arc length is a fraction of the circumference.